All right. Atomic structure, how the atom is put together. All atoms are the smallest particles of any substance, anything that makes up matter, anything that has space, weighs something, and they all have the same type of particles. So the subatomic particles are the particles found in the atom. There are three types: the proton, the neutron, and the electron. We'll give the proton an abbreviation P, just the letter P, the neutron N, and the electron negative or E minus. Okay, so this is a simple drawing of what it might look like for us to kind of take a look at this. So if we looked at the proton, protons are here, are putting a plus in those. All right. The neutrons, so the protons are plus. The neutrons are neutral, they are zero, and the electrons are negative. And the protons and the electrons are attracted to each other. Because negative is drawn to positive. All right, so that's why the electron not move away. It can move around like you're holding a string. Protons like holding a string onto the electron and twirling it around. It can't get away. It spins around. So protons are found in the nucleus. Now the nucleus, if I take it, is the center portion. These are the particles, the neutron and the proton are in the center, and they call that the nucleus. So protons are positively charged and has an atomic mass unit of 1. So if I ask you for an AMU, that's atomic mass unit abbreviation, and that has 1. Has a charge of 1. So if one proton has 1 charge plus 1, if 2 protons equals plus 2. So it goes forward and on and on and on. So the protons live in the nucleus, the electron lives in this orbit outside. Orbit outside. Neutrons are also found in the nucleus. So I said, here are the neutrons. They're inside the nucleus. Only the protons and neutrons live there. It has no charge, but its main function, the neutrons, keep the protons from repelling each other because plus charges repel each other, push away, repel. Okay, but the neutrons are like your thumbs, can think of this as your thumb. Use your other thumb, holding those together, holding the protons together, because plus charges don't want to stay close to each other, neither do negative charges want to stay next to each other. Electrons are found in the space surrounding. So it's like that. Like I said, if proton had a string, it could move the electron around in a circle, up and down and so forth, but it can't pull it any closer, but can keep it from going, getting away. So they don't. The electrons are negatively charged. We had more than one electron, a negative one, and a plus another negative one gives us a negative two. So the more electrons we have, the more negative charges we have. Then they're really small because almost 2,000 of them to equal one proton. Because the nucleus contains a positive and neutral particle, the net charge, or the charge on this, is a plus. So that's why they have this big plus in here. Okay, and that's what's holding the electron. The force known as the nuclear force holds the protons and neutrons together in the nucleus. So the nucleus is responsible for holding the protons, and we call that force in there the nuclear force. The space around the nucleus is negatively charged because we got electrons there. Electrons orbit around the nucleus in what they call electromagnetic, because it has a negative charge. That's what the electro is, and magnetic is something that says holds. So magnetic holds things together. Like I said, that string, the positive charge here keeps the electron moving around in its circular orbit. All right. So as we said before, the electron, back up again. I'm going to draw a picture on here. The electron is the outside, the negative part. The neutron is the no charge part that sits in the nucleus. And the proton is the positively charged, and the nucleus is right here. Which of the following subatomic particles is positive? That's the proton. Which of the subatomic particles is the smallest? And that's the electron.